Hey, hello guys, welcome, Vanakam, Namaskar. And today we are going to see relations and functions of class 12 first part. So I will try my level best in order to complete this entire lesson within this one video. If not, at least we will complete relations, okay, and also some basic introduction to functions also it will be there. And as you all would have noticed, this is what my first video is with this headset, okay. So comment, is there any difference in the experience? Like, you will be having some experience with other videos, right? And also with this video, so is the voice more clear or it is not? Okay, so first we will start with relations. Before coming into this concept, you have to know all these three concepts. What are they? They are ordered pairs, relations, and functions. And by the way, I might look like a joker, but looks does not matter. You can just concentrate on the voice. Okay, so as I said that, relations, okay, before coming to this, relations, you have to know about ordered pair. Okay, so after ordered pair, we will know relations, then we will know functions. Okay, here you can see I have drawn a Venn diagram. Okay, this is what the Venn diagram is. First, ordered pair is actually something that is very important. With this ordered pair itself, you will be having the concept called as Cartesian product. Then after that, you have to learn about relations. So first we will know what is an ordered pair is. Ordered pair is very simple. Actually in our portion there is only duplet. Okay, there is only duplet. That means only two different elements can be placed in an ordered pair. That means you can see this is an ordered pair. Okay, an ordered pair. See, this ordered pair has only two different elements, which are A and next is B. Okay, actually I've recorded already this video one time, but due to some technical issues I had to go like off that video and on that video, off that video on that video, and I cannot edit, I don't have any time, so we are just seeing them all again and again. Okay, so according to our portion there is only ordered pair which has two elements in it, where this element, which is the A element, next is the B element. Okay, about this domain and range we will see later. Now if you want to learn something extra, there is also this thing which is known as n-tuplet. N-tuplet means where n represents number of elements in an ordered pair. Okay, see, you can see that there are totally three different elements in an ordered pair itself. Here there are totally four different elements in an ordered pair itself. Okay, well, normally we don't use in our relations and functions topic because domain and range only we are having, and if you cannot use this three elemented ordered pair also, but in coordinate geometry, in vectors, like in I'll just give you some basic introduction to that. I don't know that much because I'm also student, they have not taught me that much, but some basic things I know, where okay, one will be z axis, one will be x axis, and another will be y axis. Oh, huh. Okay, so x is represented as I cap. Okay, this is j cap, this is k cap. Okay, so how you are going to write in terms of ordered pairs? I'm going to erase this, it's not that much important, but just a basic introduction I'm giving. First you have to write the x axis, which means first the I cap, then the j cap, then the k cap. Okay, we will see about vectors very in detail. We will be seeing also about that lesson. This is what where like this only will be representing, just like in our coordinate geometry, where in 2D. Okay, in 2D how was it? It was just like x comma y axis, right? Here it will be like x comma y comma z axis. That's it. That's the difference. Okay, other than that there is no such difference. Okay, so this is what the ordered pair is, where inside ordered pair you will be placing two different elements. Okay, where this element will be representing the x-axis in the coordinate geometry, and this element will be representing y-axis. Very important, that x and that y. With that only it will be very helpful for us to find what is the domain, what is the range, all those things is. Okay, actually my headset got off because I did not charge it. I did charge it once, but it said only 20 minutes, but it seems half an hour is taking in order to be completely charged. So now I'm using my AirPods. Actually, the problem with me using my AirPods is that my ear starts to pain after some amount of time, within just a short span of time. So half an hour I will use it. Next, for remaining 1 hour we will use that. It is actually based on the duration of our video. Okay, so coming to here, as I said that this represents the x-axis and this represents the y-axis. And this you have to keep in your brain because in later concepts will be Also taking that one. Okay. So next is Cartesian product, where Cartesian is a mathematician, and he is the person who has introduced about this product of two different sets. Okay. So for an example, you are having set A and you are having set B. So set A has two elements which are A and B, and set B is having elements such as 1, 2. Okay. Now we have to multiply these two sets. Okay, so set A into B. Now, how will you multiply? That's a very common question. How will you multiply? Okay, this is actually a 11th standard concept, so many of you guys would have known it. If you all know this, then first 10 minutes is completely a basic introduction for relations and not for functions. Okay, for relations of our class 11th standard only, so you can just skip those 10 minutes. Okay, see here what you have to do is, since here first is A only, see you can see that the first set itself is A. Okay, so from set A you have to choose an element. It can be this element. Okay, so this element you are going to write in the first order pair. Okay, before that I have to say one thing. This color here, there is a formula that where number of Cartesian subsets. Okay, so Cartesian subsets, that means how many subsets you will be getting. Okay, how many subsets you will be getting when you are multiplying two different sets. Okay, or even three different sets. That's okay, because it's very simple. It is going to be number of subsets. Now I will write it like this: n of A into n of B. That's it. Okay, n of A into n of B, where n of A is the number of elements in set A. Okay, number of elements in set A. Here it is, number of elements in set B. Okay, which means very simple. See, here set A, this is what the set A is. Here you can see this has totally two elements in it. Okay, this is what set B is, and here it has totally two different elements, right? So according to our formula, n of A, so how many elements does this set A has? It has around 2, not around, exactly it has only 2. Okay, so I'll use this color. So 2. So so we are going to put 2 into, okay, this formula only we are substituting. Next is n of B. N of B is also having 2 only, so 2 which is equal to 4. So and also you can see that here also it is 4 only, which is 1, 2, 3, and then 4. You can see that there are totally 4 different subsets that are being produced when you are multiplying set A and set B. Okay. Now, how will you multiply that? That's what the question is, right? I do not want to erase this. Okay, let it be. No problem. Okay, so how will you multiply this? First is, you have to take an element from set A. So I'm going to choose this element, and first you have to write that in the first order pair. Then you have to choose an element from set B. So I'm going to choose this element. Then you can write it as here. Okay. See, remember this one point, that is, if in case when you are multiplying, if they are given this one point also, I have to say, that is, okay, set A into B is not equal to set B into A. Okay, that is completely different. So here you can say that, so this is what the first set is. So you have to choose an element. First element you have to choose from set A only, because here this is what the first is. So A, then after that second is C, B only. So from B you have to choose an element. Like that you have to proceed till all the elements are being related with all the elements. That means, see, this A must be related. How many elements are there in set A? Set A has like A and then B. Okay, these are the two elements. Set B has 1 and then 2. Okay. Now what you have to do is, you have to relate this A with all the elements of set B. All the elements of set A must be related to all the elements of set B. Then only the Cartesian product is completed. Okay. So that means, see, first set A has to be related to 1. Okay. Then after that you have to relate this A. Okay, sorry, I said set A, I think. Okay, this element must be related with all the elements of set B. So first is this one, then next is this one. Okay, then after that, same applies to B. So this also should be related to this, and then also this. Okay, so if you just write it, since it is A into B, so it is A into B, and this is what A is, and this is what B is. So when you're writing, you have to write it as A comma 1. Okay, then it is B comma 1. Okay, then it is A comma 2, and then here it is B comma 2. Okay, so that's it. This is what the Cartesian product is. Now I hope you can do it with all the with other sets also. Like if they have given here 3 elements in place of 2 also, then the same thing applies. Like this only you have to do. Okay, next is there is a concept in set itself which is like contains elements. Okay, that is all in the sets. We will be just giving like 1 minute introduction to that because we want it. Okay, because we want it. Now we will be actually going into relations. Here even we will see. Okay, so here relation. Actually there should be, actually I have notes over here. We will do with this itself. Normally other YouTube channels, if you check, they will be having a PowerPoint presentation where already everything would have been written, but I don't have time for that. Okay, see here, actually the definition for relation is A and B are two non-empty sets, then the relation R from A to B is a subset of A into B. Okay, so now we have to know what is a subset, what is an element, what is the difference between element and subset. That is why sets is very important of class 12th, sorry class 11th. Anyone who's not that good in class 11th, they might struggle a bit in class 12th. Not might, they will suffer, I think. Okay, so for an example, let us take that A set. Okay, A can be, wait, I have a very good example. Okay, so actually I thought I had that note, but I had given it to a brother. That is why I'm not having it. Okay, so I will give my own example, which is then 7. Okay, so this example itself is enough to understand this. Believe it or not, this might be a little bit confusing, but this is a very simple concept. Don't worry, it will be very simple when I have completed this sum. Only one thing that you have to know. Okay, only one thing that you have to know before entering into this concept, that is this one, which is small should be written over here, and then big must be written over here. Then the symbol must be written over here. Okay, nothing will make sense. I know that. When we are doing it, it will all make some sense. Okay, so come. We will now do this sum. First is we will write element of. Okay, is an element of. Is an element of. Okay, the symbol for this phrase is actually this one, and it contains. Okay, it contains symbol is this one. Okay, so this one is there. Then okay, so look here. You can see this is a set. Okay, so this is a set. Here, what you are going to do is you are going to write the element. Okay, the elements of this set A. So that means you can say that this set A, 1 is an element. Okay, 1 is an element, but when you are writing this one, since already it has brackets, okay, since see it has bracket, okay, this element already has the special bracket, so when you are writing it in the form of element, you should not remove the bracket. So the element, this has to be written like this. Okay, yeah. Like this only, you have to write where the element, which is the small thing, okay, which is the smaller unit, right? So smaller should be written like this, okay, this side, and then the bigger one, which is the set itself, the total set itself, that has to be written in the right hand side. Like that, you can remember. That is why I said. And here the sign comes, okay, like this sign or this sign. Okay, so then how will you write this one? This one can be written like this itself. Okay, then 2 also you can write it as like this itself. Okay, but this one you cannot separate. Okay, this one you should not separate, just write it like that itself. That is 3, 4, which is a. Then coming to 7, you have to write it as 7 itself. Okay, so this is what is an element of. When you have to write an element from a set, then you have to write like this. Note, there should be nothing changed. Okay, whatever is there, like that itself you have to do. Don't add any brackets, don't remove any brackets. Okay, just like that you have to add. Okay, all you have to do is don't. Okay, just like I said, don't add any brackets, don't remove any brackets. Coming to here, all you have to do is you have to add another bracket to it. Additionally, you have to add a bracket to that. That's it. That means, okay, so I'm going to choose this one. Okay, this one element, that is, this is an element. Now I'm going to write it in terms of subset. Okay, subset is like, how can we say? We can say that it has, see, this set is the senior version. This set is a senior, and we're going to write its junior, or we can say that this set is a parent, and we're going to write its children. Okay, so set A is there. For the set A, it has many subsets. Okay, actually, it has 2 to the power of n subsets. Okay, n, where n is the total number of elements. Total number of elements. Remember this formula? This formula is also applicable in case of relations. We will also see over there, and also I will explain why here and there we are having same formula. Okay, so coming to the case of subset, I am going to represent this in sense of subsets. So first you have to write the element. Okay, first you have to write the element, and along with that element you have to add another special bracket. Even though this has already the special bracket, but you have to add it. Yeah. Okay, and note this relations and function lesson is very important for upcoming chapters. Okay, then how will you represent this one? This one can be written like this. Okay, this one can be written like this. Okay, this one can be written like this. Okay, see, okay, this one can be written like. So this is how you have to do. The one and only change that you are going to do from here to here, this case, is that you are going to add a bracket. That's it. Okay, so this is what you have to know, and everything that you have written this side, right? Okay, everything that you have written. Okay, everything is actually subset, and this is what the set is. And also you can say this as the superset. Okay, this is set as superset, this is set as subset, because this set is superior to this set. That means all these sets had been taken from this set only. Okay, so every set that is over here had been taken from this set. That's it. Okay, so yeah, we have done this, we have done the Cartesian products. Now only we are going to enter into the topic called as domain and codomain. And please remember that, okay, so please remember that domain is the x-axis, and range is the y-axis. Now only we are going to enter into our concept called as relations itself. Okay, and this I will explain also, this also I will explain, don't worry. Before that, okay, before entering into this concept, we will just have a basic idea what is a relation, what is a domain, what is a codomain, what is a range, and what is a function. Very basic idea, don't worry. It's a very basic concept. Okay, so imagine this as a mixie. Okay, this is what a mixie is, this is what the blender is. Since it is summer, okay, now it is summer, what date is it? It is 24th April 2025. Okay, and the time is actually 7:02. Okay, the time is 7:02. Okay, I've started pretty fast the video. Okay, so this is what the blender is, and since it is summer and summertime mango is very special, I like mango. I like mango smoothies. Okay, so I'm going to give here I have mangoes. Here I have mangoes. Does it look like a mango? It looks like a kidney. Now it looks like a moon. Oh, see, it cannot even find it. Okay, let us say it has a banana smoothie. Okay, no. It has some other meanings. How to draw a mango? Is this okay? There is no mango. Okay, so let us write as mango itself. Okay, so I have mango over here. And this mango I'm going to give it to the mixie. Okay, that means to the blender. Mixie is the English word, I think. Okay, and then you are going to get out as mango smoothie. Okay, as mango smoothie you are going to get it. Okay, and also when you add some other additional ingredients to it, like you're adding ice cream to it, you're adding milk to it, you're adding more sugar to it, this is natural mango smoothie. That means no sugar is being added, no ice is being added, just mango is being added, that's it. Okay, so just mango flush, you can say, that's it. That's what being added, and it is being blended, then you have taken it. Then when you're adding some other additional things, is now it has become as mango milkshake. Well, in general, I like only mango milkshake. I don't like mango smoothie. But for our educational purpose, we are going to take that. I like mango smoothie. Okay, I don't like mango milkshake. That means I don't want mango milkshake. I want only mango smoothie. Okay. See, this is what the mixie is. Yes, right. So this is what the device. Okay, that is giving you that relation between mango and mango smoothie. Can you understand? This device is something that is providing a relationship between mango and in the mango smoothie. Okay, here the input. Okay, this fruit is the input to this device. Okay, so this input is what's said as domain. You can give any input. For an example, instead of mango, you can also give the apple. Banana also you can give there. Strawberry also you can give there. Also other fruits also you can give there. So domain is something that you can mostly, okay, mostly domain will be bigger than codomain. Mostly, but there is no such condition that domain should be bigger than codomain. But I said the word mostly. Mostly is different from always. Okay. So this is what the domain is. This is what the input is also. Okay, input. Oh, it has dual color, right? So input. Okay, and this is what the function. And I said that there is a relationship between mango and mango smoothie, right? That is what the relation is. That is what the relation is. Okay, and this, all these are codomains. Okay, codomains. Okay, and I said that mango smoothie is the natural mango smoothie, and mango milkshake is where you have added the mango ice cream, you have added the milk, heavy cream. Also, you would have added normal milk. Also, you would have added sugar. Okay, so because all these things had been added, you can take it as, okay, you just take it as that there is no relationship. Okay, there is no relationship between mango and mango milkshake. Okay, we will take it as fruity, not fruity, maza. Okay, maza. The maza which they sell as the mango juice is not at all having any relationship with mango. It's all completely artificial, right? Okay, it is all okay. So let us take that maza. It is all completely artificial. So we don't know whether it is not, but we will take it as it is completely synthetic maza. See, maza, and this mango and then this maza is not having any relationship at all. Is not having any relationship. Okay, but with mango and with maza, okay, from this mango, some parts of this mango, that essence you can extract and then you can make maza, not in your home, in the industries, but there is no relationship between maza and mango. Okay, so these two are having relationship and this is not having the relationship. Now, all these three, that means Maaza, mango milkshake and mango smoothie. Okay, all these three are known as codomains. Okay, no matter whether it has a relationship or not. Okay, whether it is single or it is committed, that we don't care. Whether, okay, from this you can take this or not. That's the one and only thing you have to discuss. Okay, see, so all these three are known as codomain. We don't care whether it is committed, whether it is loving or whether it is not loving. Okay, next is you can see that this part, this is there, right? This has a relationship with this one, okay, but this does not have a relationship. So what you're going to say is that these two are known as range. These two are known as range. Oh god, yesterday also I did not explain this code. Today I'm very much satisfied. Okay, so this is mango milkshake, this is mango smoothie, this is mango milkshake, which has a relationship with this input. So this is known as range. Okay, done. This is what the basic concept is. Now coming to the mathematical form, I'm going to explain it. Imagine this is the input, this is the domain, this is the mango. Okay, this is the output. Okay, this is what the codomain. Okay, this has the range, and then this is what the milkshake, or this is what the smoothie, or this is what the masa is. Okay, so here only all the input values are there. For an example, it can be 1, -1, -2, -3. You keep it as. Okay, it has become as 1, 2, 3. And then 4 is also there. Okay, now like this it is. See, this -1 has become as +1. Okay, -2 has become as +2. -3 has become as 3. Okay, -3 has become as 3, and there is 4, there is no such thing. And also I said that mostly only, and here I have wantedly concluded that codomain is bigger than domain. Okay, then only it will be fixed to your brain that there is no such rule, just mostly is what there, because in functions it is always. In functions it is always, but in relations there is no such condition. Okay. So now this is -1, this is +1, right? There is something, okay, something has happened, some magic has happened. Okay, where that magic has converted this -1 to this +1. Same thing applies to -2. That magic is the thing that is responsible for the conversion of -2 to +2. Actually, it is just the modulus function. Then that same magic is happening over here also. Don't worry about modulus function also. You'll be studying very correctly. And also, yes, I said the word very correctly. You have to know that means what. That means different. Okay, from correctly. Very correctly is different from correctly. Okay, it is not superlative degree, it has something other meanings also. Okay, so -3 has become as just normal 3 by that modulus function. Okay, and there is no option like 4, -4, so you cannot draw a relationship for that. Okay, so here this is what the input value is. Okay, and imagine that these lines are those missions. Okay, the mission. Okay, the modulus function, here there is a function. Okay, here there is a function. That function is none other than the modularity. Okay, so -1 has been converted as +1 by the function. Okay, and it will be having always a relationship R. And note that I hope till now everything is clear. There is no doubt. If there is any doubt, you can ask in the comment section. Okay, so this is what the domain is, this is what the range is. See, I have converted all these elements by this. Okay, only thing is, here it is not modulus function, here it is just -x function. That means whichever is here as positive, that has got converted into negative. Okay, negative numbers, negative integers. Okay, see. Okay, -1, -2, -3, -4, -5, and -6 is there. 1 second, I'm thirsty. Okay, see, actually now before going into this concept, also one thing you all would have got this doubt. Where is my spectacle? Okay. Oh, So you all would have got this one out. That is, what is the difference between a relation and what is the difference between the function? Okay, what is the difference between them? Actually, relation and function are very same. Okay, are very same in sense, very similar they can say, not very same. That means different. Okay, so are very similar. Function is a special type of relation. Know this one point, it is very important. This page is not good. I'm right here. Function is a special type of relation. Okay, and there are some differences. Okay, there are some differences that we will see later on. Okay, so till now we are in basics only. We are covering basics because basics are very important. Okay, now you will be having two different doubts. What are those two doubts? Are those things which I'm about to say. Okay, these doubts, all those doubts which I'm saying now, right? Or these which I had when I was studying in 11th standard. Then they all got clarified. Okay, and as I said that the difference between them. Okay, the difference between a function and relation, I'll say as in other slides, okay, as in the future slides. Future slide in sense, in this video even we'll complete about it, don't worry. Okay, so coming to here, see, the doubt number one is that whether can an element in this domain, okay, so this is what the domain is, okay, which is the x-axis, this is what the range is, which is the y-axis. I'm saying it again and again because that is kind of important. With that only will be here. We will be reading inverse trigonometry completely. Yeah, also functions also very important. It is actually kind of like a golden rule and a very golden point you have to remember. With this only you will be able to find just by looking graphs itself you can find what is the range and what is the domain. Okay, see, the doubt number one is that whether can an element which is in the domain can have more than one relationship. Actually, compared to the real life, we now I cannot say this, it'll be like offending our generation. Many of us are in situationship, not in relationships. Yes, right? No one, many of our generation are not being committed. They are being committed to the situation, not to the person. Okay, it's what's said as the situationship, like that, so that they can have more than one situationship. But relationship should be only one. Situationship can be more than one. It's an excuse that they give. Okay, like that, the answer is yes. Okay, this element can have more than one relation. But here, since I've defined that this is what the function is, for an example, okay, wait, I've taken also that screenshots. Actually, the screenshot is not important because I can give it by my own itself, but feeling kind of lazy to think. Okay, so doubt one. I'm even creating doubts and I'm even answering them. Oh, okay. By the way, this is what the spelling of doubt is. When I was studying in 10th standard, one day I came to know. This is falling. Okay. For example, okay, let's say like relation, not this color. Okay, relation is equal to 1, 2, then 1, 3, then 2, 4. Here you can see that 1. Okay, 1. One important point. I don't know why I'm making some noises. Okay, so this here you can say, how will you represent these two in terms of ordered pairs? How will you represent all these in terms of ordered pairs? It's kind of simple. That is, domain should be represented in terms of x-axis and range should be represented in terms of y-axis. That means I will represent this and this relationship first. That is 1, -1. Okay, this relationship and in this relationship, which is 2, -2. Okay, this one, so you have to write it as 3, -3, then 4, -4, then 5, -5. Okay. Make sure that you put special bracket. Okay, so here also it is like the same thing. That is, here is the right. So this is for the x-axis. What did I say? X is the domain. Here also, this is what the axis and this is what the domain is. You can see that here also it is 1 and here also it is 1 only. So 1 is having a relationship with both. 1 is having a relationship with both 2 and 3. Okay, so how will you draw this diagram? Okay, how will you draw this map diagram? 1, okay, 2, then 2, 3, and then 4. Is there right? Okay, see, all the numbers I'm talking about. Okay, all the x part of the ordered pair, that means this part, okay, this part and this part must be written in the domain, and all the y part, that means 2, 3 and 4 must be written in the range. Okay, then what you have to do is now you have to map. See, 1 is related with 2, right? So 1 and 2 you have to map. Then 1 is related with 3, right? So 1 and 3 you have to map. Then 2 is related with 4, right? So 2 and 4 you have to map. Okay, so this is how it is. So as I said that, yes, an element from the domain part can have more than one relationship to the codomain part. Okay, but in functions this is not applicable. This is what the first difference, and I think this is what the difference is itself. Okay, the total difference itself is, okay, note, this is applicable one and only, okay, one and only for relations, not for functions. Functions, okay, in function, okay, in a function you cannot have, okay, a domain, okay, an element which is in the domain cannot have more than one relationship in the codomain, okay, or in the range. That is not applicable in functions, okay, but in relationship it is applicable, because see, you can see here itself, function is actually something which is inside the relation only. Okay, so you can say that every function is a relation, but not every relation is a function. Okay, next is doubt 2. This is falling. Okay, so doubt 2, what is that? That is, how will we represent, okay, how will we represent this one if an element from the domain is not being mapped? Okay, an element from the domain is not being mapped, and is it okay that can we leave an element in the domain to be not mapped? That means, see here, B is not being mapped, right? Whether it is correct or not, whether it is a relation or not, yes, it is okay, it is applicable, that is also a relation only. B is, it's okay, it's actually accepted, this is a relationship only. Then how will you write its ordered pairs? H is written in, okay, so first you can say that, okay, 1 is being related to, A is being related with 1, okay, A is being related with 1, then C is related with 2, okay, that's it, okay, that's it, like this only you have to map. But when you are drawing the diagram, when you are drawing this diagram, you must put B also over there, okay, you must put B also over there, do not forget B over there, that's a big crime, okay, that is a big crime. Then this one point I have to explain, codomain, and also one more point also is there, that also we have to see. My ears are paining. Okay, so first is, see, all these are what? All these are range, yes, right? And then this is the unmapped version. Okay, when you add this range and then these unmapped elements, okay, plus unmapped elements, you will automatically get codomain. So from that itself you can say that codomain will be always bigger. Okay, codomain will be always bigger than, or always, not always, sorry, codomain can be bigger or equal to range if in case every element over here, okay, if in case every, we will not over there, this is where it is, okay. So if in case every element in this place, that means for an example this phi is also being mapped to here, okay, since here function is being defined, I cannot map it like that, but for an example, if this function is not being defined, then here phi can be also mapped to -6, okay, phi can be also mapped to -6. Okay, so here you can see that every element in the codomain has been mapped, so here everything is with a range, so codomain is equal to range. And also note this one specific condition, because it is important for our class 12 in functions. There is one topic itself, okay, that is a very important topic that we will be seeing. I will say the name, which is onto, which is known as onto, okay. No, it is not that good. Okay, so next is yes. one more last point, that is going to be so is this okay? This representation will not be familiar with many of us, even though I said here. Where did I say? Over here we have seen that. Okay. See, this opening part is there, right? This opening part always should be opening towards the bigger one. Okay, like you have to always aim very big. For example, I daily aim about 100 gulab jamuns, but I don't even get one gulab jamun. But that's not the case. Like that, you have to actually aim towards the bigger part. Like that. Here, this is actually, see, it's opening towards the bigger set only. That is the superset. Okay, like that, you can see that. See, here also it is being open to the codomain only. Yes, right? Here also it is being open to the codomain only. Like this also you can say, in order to remember, I'm saying, okay, in order to remember, you can write it as like this. Okay, then one point is there. That's something I'm going to write over here. Okay, so here in definition, even I've written that is a subset of A cross B. Okay, it's a subset of A cross B. This is what the last point in basic is. Now we will be entering into the advanced concepts. Advanced or 12th concepts we can say. Okay, see, when A and 2 are non-empty sets, okay, when A and 2 are non-empty sets, then the relation from A, okay, this is what A is, and this is what B is. Okay, from A to B is actually a subset. Okay, it's actually a subset of A cross B. How? Well, if I take this example, then it will take a large amount of time. We'll take a new slide. For an example, yeah. This is what A is, this is what domain is, this is what codomain is, this is what B is. Okay, so I'll take only how many elements shall we take? 1, 2, 3. A and B we will take. A and B we will take. That's enough. Okay. So what is this? This is what set A is there. Right? This is what set A. So, oh God, I've improved in handling the smart board. Okay. So set A into B only this. Okay. So first we are going to find what is set A into B. Very simple. I've already said to you all. 1 comma A, then 1 comma B. Okay, then 2 comma A, then 2 comma B. Okay, then 3 then 3 comma. Just now I said that I have improved in handling the smart board and it has started happening. 3 comma A and then 3 comma B. Okay, now let the relationship be. Okay, so this is what the given question is. Like A to B it is being connected and like this it is being connected. Okay, and also make sure that you are putting arrow marks. Arrow marks are important. Arrow marks are here. Here also arrow marks are there. Okay, here also arrow mark is there. Okay, so I've got all these. Now the thing is, for an example, this is what the relation is. Okay, this is what the relation is. Then that means what is the relation? Relation. But I don't have a relation. Okay, so coming to here, it is going to be 1 comma A, then it is going to be 2 comma B. Yes, right, this is what the relation is. Now, when you notice this, this relation is a subset. Okay, this relation is a subset of this superset. Okay, this A cross B's subset is what this relation is. See, this 1 comma A and then this 2 comma B is there here also. Yes, right, what I said. When you can also write in terms of classes, that means you can also add over here. Here. See, also I can write like this. See, this is not just number of total what? This is not just total number of subsets. Subsets are more. Okay, how many are there? 1, 2, 3, 4, 5. So 2 to the power of 5 is what the answer is. Okay, total number of subsets. Here you can also write it like this. Okay, so 1 comma 2 is actually a subset of A, like this also you can write. You can add two different elements in a and you can put that in a subset, and then you can say that this is a subset of A, like that also you can write, like that when you have written over here. See, I've added this and I've put, and this is a subset. Everything is clear, right? Okay. Now that means what? In case, if I map like this, okay, then you will get this, okay, this as the relation itself, this total thing which I have written, right? Okay, that is what the relation itself will be. Okay, that one part will be the relation itself. Okay, so that is why the formula for total possible number of relations, not for exactly total number of relations, total number of possible relations. Okay, for total number of possible relations, for total number of possible relations are what are 2 to the power of total number of elements, are 2 to the power of total number of elements, right? In, okay, so yes, this n is the total number of elements in this, okay, in this Cartesian product. Okay, n is the total number of, okay, n is the total number of elements in the Cartesian product, okay, in the CP. Okay, so this is what the basic introduction for relation is, and I'm pretty satisfied with my explanation because I think complete 11th standard relations we have covered. Complete. Okay, and this n also has a formula. This n also has a formula, right? What is that? N is what? Total number of n is what? Total number of elements are, sorry, total number of subsets. Sorry, wait, what is that? Total number of ordered pairs, you can say. Yeah, total number of ordered pairs. Total number of ordered pairs. Okay, total number of ordered pairs, which is 1, 2, 3, 4, 5, 6. 6 ordered pairs are there, so we are going to count it. So here the total number of relation is going to be total number of possible is 2 to the power of 6 is what over there. Then one thing I came to say, what is that? I don't prepare for any seminars. So the n formula, what is n formula? N formula is going to be n is equal to n of A into n of B. Okay, if n of A is equal to n of B, this is a 1 mark question. I'm sure that 80% sure that this question will be coming to your 1 mark question, so you can just like that take the answer, okay, without any confusions. Okay, if it is equal, then how will you write? So n is equal to n of A the whole square, right? Okay, so let okay, so like this it is what there. So then put this in this formula. Okay, so 2 to the power of n, in place of n you are going to put this formula. So n of A to the whole power of square. So it is like square, it is like square. So that's it. Okay, that's it. This is important. Okay, so till now we had an amazing recap. Now we will go into our concepts deeply. Okay.